Let's consider reference angles. Now, a reference angle, what we're doing is we're relating the term when we're on the coordinate plane, got angles on the coordinate plane. We are relating that terminal side to its nearest x-axis, if you will, nearest place on the x-axis. And there are certain formulas depending upon which quadrant you're in, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And while I'm at it, because this will come up next, when we're on the coordinate plane, think about all students take calculus. I just bring that up. All the trig functions in the first quadrant are going to be positive. In the second quadrant, all the sine functions and its reciprocal cosecant are going to be positive. Everything else is going to be negative. In the third quadrant, the tangent and cotangent will be positive. The sine, cosine, cosecant, and secant will be negative. And in the fourth quadrant, the cosine and the secant functions will be positive, but the sine, cosecant, tangent, cotangent will be negative. That's going to come up later, but why not take the opportunity to do it? All right, so now with the formulas that you see for quadrant 1 and quadrant 2, 3, and 4 in your book on page 808, they only work if we're talking about a positive, if we're relating it to a positive angle. In this case, we have graphed here a negative 110 degree angle. And so we've moved clockwise from the standard position where the origin is the vertex, and we've moved in this direction, negative, we call that negative 110 degrees. But if I think about what's my positive coterminal angle, if I come around this way, let me do that in a different color. Well, maybe it's not going to erase. Huh, interesting. Well, I'll just draw it again. If I come this way, oh, I did erase. If I come this way, well, that would be 250 degrees. Correct? Now, what I'm trying to find, and I'm probably going about this, you probably got this figured out in your head a whole lot quicker than what I'm doing, but I'm just trying to illustrate. I want to find the measure of that angle right there. And in quadrant 3, we have a formula that theta prime, which is our reference angle, theta prime, is equal to theta minus 180. And the reason why I say if I just use that negative angle, it doesn't work. I'd have negative 110 minus 180, that'd be negative 390, and that's not going to work. But if I use that 250, if I use the positive coterminal angle, then I've got 250 minus 180 to where my reference angle, theta prime, is 70 degrees. Now, you might just say, well, if this is 180, which I know it is because that's 90, this is 270, this is either 0 or 360. Well, what's 180 minus 110? That's also 70 degrees. Common sense can also tell you that. But if I'm trying to use that formula, I'm going to have to go and find the positive coterminal angle to that negative 110 degree angle. All right, let's do another one, but let's do one in radians this time. All right, it says find each angle, find its reference angle, and our angle is 2 pi over 3. Now, one thing to note, anytime I'm in radians and I see a denominator of 3, I know that this is somehow relating to something, a multiple of something 60 degrees. All right, and so it's 2 times 60, right? Pi over 3 is the same as 60 degrees. I also know that when I'm in radians that this is pi over 2, and this is at the x-axis here is pi, and this is 3 pi over 2, and this is 2 pi, or 0. Let's just say 0 or 2 pi. Okay, well, if I'm 2 pi over 3, then I'm going to be in the second quadrant because that's going to be greater than pi over 2, but it's less than pi. And you see here, I actually entered 2 pi over 3, but you see that it related it to 120 degrees. Okay, because in radians, it did its own radian to degree conversion. Now, so my task though is, what is this reference angle from that terminal side down to the nearest x-axis, which is right there? Well, then I can say that the reference angle, theta prime, is equal to pi minus theta, and theta is 2 pi over 3, so theta prime then is pi minus 2 pi over 3. And of course, if I'm going to add those together, I've got to convert that pi into something over 3, so that's 3 pi over 3, right? That's the same as 1, correct? Minus 2 pi over 3. And so the theta prime, or the reference angle, is pi over 3. All right, got to use some common sense in here, because a little bit of some of the instructions that you get are a little bit confusing. Just think about, what quadrant am I in? That's a big one right there. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. All of that, getting that fixated in your mind, is going to be important to you as we continue to move forward.